At over 6.5 million square meters, the Volkswagen plant in Wolfsburg is one of the largest car factories in the world, a place where humans and machines worked in perfect sync. In 1989, this vast industrial hub brought to life two of the most iconic German cars of the era, the VW Golf and Jetta. So, what made them so special back then? Let's step inside and find out. The year is 1989. The Berlin Wall is about to fall, changing Europe forever. Meanwhile, at the Volkswagen factory in Wolfsburg, Germany, the largest car manufacturing complex in the world, thousands of workers are streaming through the gates, ready to build what would become some of the most iconic vehicles of the era. This factory was truly a marvel of modern manufacturing. At over 6.5 million square meters, Wolfsburg was no ordinary plant. With around 45,000 to 50,000 employees working 3 shifts around the clock, this factory operated 24 hours a day, producing nearly 900,000 Volkswagen Golf cars in 1989 alone. The second-generation Golf and Jetta being built here represented the pinnacle of Volkswagen's engineering and manufacturing expertise. The workday at Wolfsburg began early. Workers would arrive and head first to the locker rooms, changing into their work clothes before heading to their stations. Despite the increasing automation, the human element remained essential throughout the factory. Many employees were second- or third-generation Volkswagen workers, carrying forward a family tradition of craftsmanship that had deep roots in the local community. Every Golf and Jetta began its life in the press shop. Massive steel coils arrived at the factory by train, and each weighing tons were transported into the facility. These coils were made of either cold-rolled or hot-rolled steel, carefully selected based on the specific requirements of each part. Volkswagen sourced this essential raw material from both German suppliers and other European producers, maintaining strict quality standards. Once in the press shop, these giant coils were fed into machines called decoilers. These specialized devices unwound the steel, straightening it before cutting it into blanks. It was a methodical first step in transforming raw metal into the familiar shapes of automotive components. The blanks then made their way to the heart of the press shop, which was a massive mechanical and hydraulic stamping press. These industrial giants used steel dies to stamp out door panels, hoods, roofs, fenders, and floor sections. The power and precision of these machines were impressive even by today's standards. Workers supervised and assisted these mechanical behemoths, ensuring continuous production while maintaining quality. But what was so special about the steel used in Volkswagen cars in 1989? Volkswagen used different kinds of steel throughout the car body. They used up to 12 different types in one vehicle. Safety areas like door impact beams used very strong steel. Body panels used steel that could be shaped into complex forms without tearing. Each steel type was chosen for specific reasons, some for strength, others to save weight, and others to prevent rust. This smart use of materials was advanced for that time and helped create cars that were safe, light, and lasted a long time. Aluminum was starting to be used in more parts, though not as much as in modern cars. Engine blocks, transmission cases, and some trim pieces used aluminum because it was light. Plastics, which were still being developed for car use, were carefully made for specific uses, from dashboard parts to fuel tanks. Supply management in 1989 was getting more advanced, but was not as good as today. Volkswagen kept large amounts of materials, fearing supply shortages. They had warehouses storing many days' or weeks' worth of important parts. Quality control began at this early stage. All incoming materials were tested carefully to make sure they met Volkswagen standards. Any problem could cause production issues later or quality problems in the finished cars. Volkswagen worked closely with their suppliers to make sure materials met exact standards. For example, glass for windows and windshields had to be perfectly clear with no bubbles or waves. Rubber for seals had to keep its flexibility in extreme heat and cold. Fabric for seats had to resist wear for many years without fading or tearing. The company was also starting to think more about the environment. They were looking for ways to use materials that could be recycled or that caused less pollution to make. This was still early days for green thinking in car making, but Volkswagen was already moving in that direction. Every single material that went into the cars was tracked with lot numbers. This meant if there was ever a problem, they could trace exactly which cars had parts from any specific batch of materials. This system helped them maintain quality and fix any issues quickly if they appeared. The change from raw steel to car parts began in the press shop. This was one of the most impressive operations in any car plant. Here, huge hydraulic presses pushed with thousands of tons of force to shape flat sheets of steel into complex body panels. The process was both rough and precise. Die sets weighing many tons were put in presses as tall as buildings. When turned on, these machines would slam together with ground-shaking force. They instantly changed flat steel into hoods, doors, fenders, and other body parts. In today's automobile factories, press shops operate with minimal human presence, but in 1989, the human touch was still essential. Workers handled the machines, monitored the stamping process, and performed quality checks on the freshly formed parts. The press shop exemplified the transition period in manufacturing, and automation was increasing, but skilled labor remained irreplaceable. Once stamped, the individual body parts moved through the factory on sophisticated sliders, which was a material handling technology that was quite advanced for its time. These components would soon converge in the welding shop, where the actual car body would take shape. In the welding shop, the transformation was dramatic. Individual metal pieces became recognizable car structures through thousands of precise spot welds. 2 copper electrodes would clamp sheets together, sending an electric current through them that melted the metal at the contact point, creating a strong bond. Each Volkswagen Golf or Jetta contained thousands of these spot welds, forming a rigid safety cage that would protect future occupants. The Wolfsburg plant was pioneering in its adoption of welding robots, especially for high-volume, repetitive joints. These machines improved consistency, speed, and worker safety. The robots moved with a hypnotic precision, their orange articulating arms reaching, positioning, and welding in a carefully choreographed industrial ballet. Workers primarily monitored these robots from control centers, ensuring smooth operation and stepping in when necessary. While these robots represented the cutting edge of 1989 technology, they still relied heavily on human oversight. Maintenance technicians kept the robots running, programmed their movements, and performed quality checks. This partnership between human and machine was essential to maintaining the high standards Volkswagen was known for. If you're finding this deep dive into Volkswagen's manufacturing history valuable, please hit the subscribe button. We have many more fascinating automotive manufacturing stories to share with you. Accuracy in the welding process was absolutely critical. Any misalignment would cascade into issues with panel fitting, paint quality, or even compromise crash performance. The welded car bodies moved on conveyor systems through the body shop toward the next major stage, the paint shop. Before painting could begin, each car body received a unique tag. This was a crucial step in the production process, as this tag determined the car's configuration moving forward. A worker personally attached this identifier to the bodywork, which would guide assembly workers about which equipment to install later in the process. What you're witnessing in this factory footage is the body welding for the second-generation Golf and Jetta. vehicles that were produced from 1983 to 1992. During this production run, this generation was built in several plants, including Wolfsburg, Brussels, and after German reunification, Zwickau in former East Germany. The Golf Mk1 was Volkswagen's best-selling model during the 1980s, a testament to both its design and the quality of its construction. Once the welding was complete, the body in white, which was the term for the welded but unpainted car structure, was transported throughout the factory on orange automated guided vehicles. This early form of factory automation helped move the heavy structures efficiently between production areas. The paint shop was next. It was a crucial step that not only provided color, but also essential protection against corrosion. The painting process began with thorough cleaning and preparation, followed by the application of primer coats. The base coat provided the visible color, and popular choices for the second-generation Golf included Tornado Red, Alpine White, Helios Blue, and Oak Green. Most painting was handled by robots, though many smaller or complex surfaces still required the skilled touch of human painters. After the base coat, a clear coat was applied to protect the color and provide a glossy finish. The entire process required extreme cleanliness and precision. All painted bodies underwent thorough quality control processes, with inspectors checking for runs, drips, uneven application, or dust particles trapped in the finish. During this period, Japanese manufacturers like Toyota were revolutionizing the industry with their production systems, emphasizing lean manufacturing, just-in-time delivery, and continuous improvement. Their factories were becoming more efficient, less wasteful, and had better quality control than many Western competitors. Volkswagen was learning from these approaches and incorporating elements into their own production. After passing paint inspection, cars moved to the main assembly line, which is the heart of the production process. Each body's unique marking guided workers at each station, telling them exactly what equipment to install on each particular car. This system allowed different trim levels and options to be built on the same assembly line without confusion. Workers operated in teams, beginning with the installation of sound insulation before attaching various wiring brackets and dozens of other components. Interestingly, even today, more than 35 years later, these tasks still must be performed by human workers. The dexterity and adaptability required for these operations remain beyond the capabilities of automation. Meanwhile, on a separate assembly line, engines were being prepared. In 1989, Volkswagen manufactured most of its engines in dedicated plants, primarily the Salzgitter facility, which was the main site for engine production, along with Chemnitz later included after German reunification. Some engine work occurred in Wolfsburg, but final vehicle assembly typically used engines shipped from these specialized facilities. Engine assembly took place on dedicated lines with specific stations for crankshaft fitting, piston insertion, cylinder head installation, and valve timing. Workers used precision torque tools and gauges to ensure specifications were met exactly. Every engine underwent testing. Quality control was particularly vital because Volkswagen had suffered earlier in the 1980s from engine reliability concerns. But how did Volkswagen test engines before installation in 1989? Every engine got cold testing, where it was connected to test equipment and turned by external power to check proper assembly and component interaction. Selected engines from each production batch also got hot testing. They were actually started and run through various load conditions on test machines. During hot testing, technicians monitored performance things like power output, oil pressure, and emissions. Computerized systems checked for unusual sounds or vibrations. This two-part testing approach caught problems before engines were installed. This greatly reduced the chance of problems in customer vehicles. As engines were being completed, chassis assembly was taking place elsewhere in the factory. This work demanded physical strength and technical skill as workers fitted suspension components, brake systems, and steering mechanisms. The marriage of chassis and body was a critical moment in the assembly process. In offices adjacent to the factory floor, engineers were working with the first generation of computer-aided design systems to draw all the components of the car in electronic form. This digitalization was where the biggest advances would be made in coming decades, allowing for better development and improvement of future car generations. Many people might be surprised to learn just how much automation was already being used in car manufacturing back in the late 1980s. Automated assembly lines were playing a growing role in the production process, especially in areas requiring strength, precision, and repeatability. Industrial robots handled tasks like installing underbody shielding, positioning and securing both front and rear axles, and even mounting the entire engine and transmission unit into the chassis. While much of the assembly line still relied on human hands, the integration of robotics marked a major step toward modern high-tech car production. You can see this blend of human craftsmanship and emerging technology throughout the Wolfsburg factory. As assembly progressed, components like the distinctive front grille were installed. The Golf's grille featured black plastic horizontal slats, integrated cleanly between the headlights to give the front a sharp, functional look that would become iconic. Each addition brought the vehicle closer to completion. Eventually, each car received its first fill of petrol and was started for the first time. The distinctive purr of the engine signaled the transition from assembly project to functional automobile. Final quality control was designed to ensure that every vehicle leaving the factory met Volkswagen standards. It was the last checkpoint before a car was sent to dealers, so any errors caught here were vital to maintaining brand reputation. Workers visually examined the entire car exterior for paint imperfections, panel gaps and alignment, trim and badge positioning, and proper assembly of mirrors, lights, and handles. Interior inspections were equally thorough, covering seat and dashboard fitting, material defects or stitching issues, and switch and control layout consistency. Engine and control functions were tested from the driver's position, checking that everything operated as designed. In 1989, women made up a relatively small percentage of factory floor workers in the automotive industry, including at Volkswagen. Women were more commonly employed in quality control and inspection roles, where attention to detail was paramount. Many adjustments had to be made to fully assembled cars, such as headlight alignment, a critical safety feature that required precise calibration. The workplace culture at the time was still largely male-oriented, with limited accommodations for female workers in locker rooms, uniforms, and work schedules. This would gradually change in the coming decades as automotive manufacturing became more inclusive. Quality control teams included trained inspectors and line workers with specialized roles. Some were rotated from earlier stages of production for cross-checking, bringing their specific knowledge to the inspection process. Volkswagen began introducing internal quality circles in the late 1980s, inspired partly by Japanese practices, where workers suggested improvements in quality and efficiency. This was an early form of the continuous improvement philosophy that would later become standard. Pay at Volkswagen factories was competitive compared to other jobs in Germany. Factory work at Volkswagen was generally well compensated for blue-collar workers, with regular pay reviews negotiated between the union and the company. This contributed to worker loyalty and the multi-generational employment that characterized Volkswagen's workforce. After passing through the factory quality checks, cars were taken to a test track near the production hall. This test drive was the final verification that the vehicle met all performance and safety standards before being sent to dealerships. While many cars underwent thorough static checks like engine testing, brake system verification, and electrical inspections, The test drive evaluated real-world performance and handling. Beyond this visible production process, Volkswagen operated sophisticated crash test facilities at their headquarters in Wolfsburg. These test centers included long crash tracks, where vehicles could be accelerated using hydraulic or cable-driven systems and then impacted into solid barriers or other vehicles under tightly controlled conditions. The year 1989 marked a major milestone in Volkswagen's history, as the company produced its 50th millionth car. Reaching 50 million vehicles demonstrated Volkswagen's enduring appeal and ability to maintain strong sales and a loyal customer base across the globe. The second-generation Golf and Jetta were built on what Volkswagen called the A2 platform. This was a very new technology back then. They also used old-style drawings and real-world testing for this. Volkswagen engineers had taken the first Golf design and made it better and more advanced. By 1989, the A2 models were fully developed products. First shown in 1983 and 1984 in North America, the design had been made better over several years. Engineers had planned every part down to the smallest bolt. They made detailed drawings and rules that would guide how the cars were built. This platform was a significant evolution from the first generation, offering improved safety, better handling, and more interior space. The platform approach allowed Volkswagen to share components between models, improving manufacturing efficiency while maintaining distinct vehicle identities. The body structure featured improved crash protection compared to earlier models, with reinforced passenger compartments and designed crumple zones. Safety was becoming an increasingly important selling point, and the production process included numerous checks to ensure these safety systems were properly implemented. As cars moved down the assembly line, interior components were installed. Dashboards arrived pre-assembled from supplier facilities with wiring harnesses and electronics already integrated. Seats, door panels, and trim pieces followed in a carefully orchestrated sequence. Workers had to be mindful of not damaging the freshly painted surfaces while installing these components. Each car's electrical system underwent thorough testing before final assembly was completed. Technicians checked that lights, indicators, wipers, and other electrical components functioned properly. Any issues were addressed before the vehicle moved to the next station. This electrical testing became increasingly important as cars incorporated more electronic features. The addition of the engine, known as marriage in automotive manufacturing terms, was a critical moment in the assembly process. The powertrain was raised from below and carefully aligned with mounting points on the body. Robots guided the powertrain in position and secured it with precisely torqued bolts. This process required both mechanical precision and physical strength. In 1989, the Golf and Jetta were available with several engine options. Gasoline engines ranged from economical 1.3-liter units to more powerful 1.8-liter versions. Diesel engines were growing in popularity, particularly in Europe, with both naturally aspirated and turbocharged options available. Each engine type required slightly different installation procedures and connections. Once the powertrain was installed, fluids such as engine oil, coolant, brake fluid, power steering fluid, and windshield washer fluid were added. Each fluid level was checked and adjusted as necessary. This was followed by the installation of wheels and final underbody components. The completed car then underwent a series of functional tests. The engine was started and run at various speeds, while technicians listened for unusual noises and monitored gauge readings. The alignment was checked and adjusted if necessary. Brakes were tested on specialized equipment to ensure proper function and balance. Headlights were aimed precisely using alignment equipment. Water testing was particularly important. Each vehicle passed through a water test booth where powerful sprays simulated heavy rainstorms. Inspectors inside the car looked for any signs of water infiltration around doors, windows, sunroofs, and body seams. Any leaks were documented and repaired before the car could proceed. The final drive test evaluated the car's performance in actual driving conditions. Test drivers followed specific routes designed to reveal any issues with handling, braking, acceleration, or comfort. They listened for squeaks, rattles, or wind noise that might indicate assembly problems. These drivers developed a keen sense for how a properly built Golf or Jetta should feel and sound. If you're enjoying this in-depth look at Volkswagen's manufacturing history, please consider subscribing to our channel. Your support allows us to continue bringing you these detailed explorations of automotive heritage. Quality control documentation in 1989 was still largely paper-based, with inspection sheets following each car through the assembly process. These documents recorded checks performed, issues found, and corrections made. This paper trail provided accountability and allowed for tracking of recurring problems. Today, these same processes would be handled by computerized systems, but the fundamental approach to quality verification remains similar. The production schedule was carefully managed to balance efficiency with quality. While the goal was to produce as many vehicles as possible, rushing could lead to mistakes. Supervisors monitored the pace of work, adjusting as needed to maintain the right balance. Workers were encouraged to report problems rather than passing defects down the line. Logistics was another critical aspect of production. Just-in-time inventory systems were beginning to be implemented, reducing warehouse costs but requiring reliable deliveries from suppliers. Components had to arrive at the factory in the right quantities and at the right times to prevent production interruptions. This complex choreography of parts and materials was managed by a dedicated logistics team. The factory environment itself was challenging. Noise levels were high in many areas, particularly in the press and welding shops. Heat was an issue near ovens and curing areas. Physical demands varied by department, with some roles requiring strength, while others demanded fine motor skills and attention to detail. Workers adapted to these conditions, developing the specific skills their positions required. The fall of the Berlin Wall in November 1989 had significant implications for Volkswagen's production. As East and West Germany began the process of reunification, Volkswagen quickly moved to integrate Eastern automotive facilities into its production network. The Zwickau plant in former East Germany would soon begin producing Golf models, bringing Western manufacturing techniques to the Eastern workforce. For many workers at Wolfsburg, 1989 was a time of both pride and uncertainty. Pride in the quality and popularity of the vehicles they produced, but uncertainty about the changing automotive market and increasing global competition. Japanese manufacturers were gaining market share with reliable, efficient cars that challenged European dominance. Volkswagen was feeling this pressure and working to adapt its production methods accordingly. The second-generation Golf and Jetta represented what many consider the golden era of Volkswagen design and engineering. These were practical, well-built cars with a touch of driving pleasure. These weren't luxury vehicles, but they offered a level of refinement and solidity that exceeded their price point. This value proposition was built into every stage of the manufacturing process, with attention to detail that created cars that often lasted far longer than expected. Environmental considerations were beginning to influence production methods by 1989. Volkswagen was implementing improvements in paint shop emissions, waste handling, and energy efficiency. While not yet the primary focus, these environmental initiatives would grow in importance through the 1990s and beyond. Some of the earliest changes included reducing solvent emissions from painting operations and improving recycling of production waste. Volkswagen's relationship with labor unions was generally constructive during this period. The company worked with worker representatives to address concerns and negotiate fair compensation. This collaborative approach helped maintain productivity and quality even during challenging economic times. By the end of 1989, a completed Golf or Jetta would make its way to the factory's massive parking areas, awaiting transportation to dealerships across Europe and beyond. Cars destined for export underwent additional preparation, including protective coatings and coverings to prevent damage during shipping. Specific modifications were made for different markets to comply with local regulations and preferences. The North American market received specially adapted versions of both the Golf and Jetta. These cars featured different headlights, bumpers, and emissions equipment to meet US and Canadian regulations. Interior features and options were also tailored to American preferences. These adaptations were planned into the production process from the beginning, with specific assembly stations handling market-specific components. While we have focused on the technical aspects of manufacturing, it is important to recognize that the real story of how the Golf and Jetta were built in 1989 is about people. Tens of thousands of skilled workers brought these vehicles to life. They applied expertise passed down through generations of German industrial craftsmanship. At the Wolfsburg plant alone, over 60,000 employees were involved in vehicle production. Many had decades of experience. They had built multiple generations of Volkswagen models. Their collective knowledge was an invaluable asset that no amount of automation could replace. Workers typically underwent extensive training before taking positions on the production line. Many came through Germany's famous apprenticeship system. They spent years learning their craft under the guidance of experienced mentors. This system created a workforce with exceptional technical skills and deep understanding of their specific responsibilities. The relationship between workers and management at Volkswagen had evolved to become more cooperative by 1989. The company had pioneered works councils that gave employees a voice in decision-making. This approach created a sense of shared purpose and commitment to quality that showed in the finished product. Despite increasing automation, human judgment and skill remained essential. Robots could perform repetitive tasks with precision, but human workers provided the adaptability and problem-solving that made the overall system work. They could spot unusual situations, make adjustments quickly, and apply experience-based knowledge that machines could not match. The factories operated around the clock with multiple shifts. Morning shift, afternoon shift, and night shift workers all did the same jobs with the same high standards. The production lines rarely stopped, except for scheduled maintenance or model changeovers. Worker safety was taken very seriously. Protective equipment was provided, and safety protocols were strictly enforced. Ergonomics was becoming more important too. Workstations were designed to reduce strain and prevent injuries. Tools were balanced to minimize the physical effort needed to use them. Many specialized roles existed beyond the assembly line workers. Tool and die makers maintained the massive presses and dies. Electricians kept the complex systems running. Maintenance technicians serviced the robots and other automated equipment. Quality inspectors verified that standards were being met. All these roles were essential to the overall operation. The manufacturing processes used to build the 1989 Golf and Jetta were not fixed. They represented the current state of continuous evolution. Volkswagen had embraced the concept of Kaizen from Japanese manufacturers. This means always seeking ways to enhance quality and efficiency. Teams regularly analyzed production methods. They looked for opportunities to reduce waste, improve worker comfort, and increase quality. Workers were encouraged to suggest improvements based on their direct experience. The best ideas were tested, refined, and implemented across the production system. This philosophy of continuous improvement extended to all aspects of manufacturing. This included everything from the arrangement of tools at a workstation to the basic design of major assembly processes. The goal was never just to maintain standards, but to constantly raise them. By 1989, Volkswagen was also implementing early versions of what would later be called lean manufacturing principles. They were reducing inventory levels, improving process flow, and working to identify and eliminate sources of waste throughout the system. Computer systems were increasingly being used to track production, manage inventory, and monitor quality. While simple by today's standards, these systems represented cutting-edge technology for their time. They helped Volkswagen manage the immense complexity of automobile manufacturing. Engineers constantly looked for ways to reduce the number of parts needed. Fewer parts meant less assembly time, fewer potential failure points, and lower costs. For example, a part that had been made from 3 pieces welded together might be redesigned as a single piece. Process engineers studied the movement of workers on the assembly line. They used time and motion studies to find the most efficient ways to perform tasks. If a worker had to reach too far or make awkward movements, the workstation would be redesigned to be more efficient and comfortable. The company also learned from competitors. They would buy and disassemble cars from other manufacturers to study how they were built. This practice, called competitive benchmarking, helped them adopt the best ideas from around the automotive world. Innovation extended to the tools used in production. Special devices were created to make assembly tasks easier or more precise. Many of these tools were designed by the workers themselves, based on their daily experience with the tasks. Volkswagen also invested in training programs to keep workers' skills up to date as technology changed. This ongoing education helped ensure that new methods and equipment could be quickly adopted when they became available. So what aspects of this 1989 manufacturing process do you find most impressive compared to today's ultra-automated factories? Do you think something was lost when human hands played less of a role in building our cars? Or is the precision of modern robotics worth the trade-off? Let us know in the comments below. If you enjoyed this video, hit the subscribe button and join us for more videos that explore how our favorite vehicles came to life.